ozone and particulates. I'm going to put those two groups together. Um, Ozone is a form of oxygen where there are three oxygens together. This is called an allotrope of oxygen. This is when an element can have two different forms, and oxygen can be diatomic oxygen or the triatomic ozone, both elemental forms of oxygen. Ozone is unstable, and in the upper atmosphere, when UV light, ultraviolet light, hits the ozone, it will break it apart into elemental oxygen and this free single oxygen atom. The free oxygen atom is very reactive, and when it bounces around and hits a O2, probably not the same O2, but an O2 from another one of these changes, it will react and form ozone again. So this is an equilibrium, and the ozone is continually regenerated and able to absorb ultraviolet light. Now, why is that important? Well, for one thing, excess of ultraviolet light can cause skin cancer. And the ozone helps to prevent this. Well, there are certain chemicals, and one of them is the CFCs, and we've talked about them before because they are also a greenhouse gas. But CFCs are gases that are very stable. Again, they're used as refrigerants, but they are very stable. Now, that's a good thing in some ways because it doesn't allow, these are non-reactive gases, so they're not going to cause problems. For example, if you breathe them, they're not really going to react with things and cause problems so much. But when they get in the upper atmosphere, and they're gases, so they can diffuse, they get to the upper atmosphere and they can interfere with this. And mainly what the CFCs do is that they will tie up this free oxygen atom so that it is no longer available. They'll actually react with it. And when that happens, you are going to lose the ability to remake the ozone. So it is continually decreasing the ozone layer. Now, the ozone layer varies between summer and winter, but overall, what has happened is there have been higher ozone concentrations in the past, and in recent years, those ozone concentrations have been getting lower and lower and lower. And you particularly see this over the poles. This represents the North Pole. And actually most people will show you pictures of the South Pole. So, that's ozone. Ozone, though, has a Jekyll and Hyde personality. In the upper atmosphere, it's a good guy. But in the lower atmosphere, it will react with other pollutants and form smog. And smog is a combination of smoke and fog. And so what we're going to have is particulates, which are unburnt hydrocarbons. We're going to have nitrogen oxides. We may have carbon monoxide in this mix. We're going to have ozone in this mixture. And then we put this all together with high ultraviolet and probably water also available, and we have smog. Now, particulates were another part of this, and to go back up here, particulates are these unburnt hydrocarbons, the black smoke, not the white smoke that you see from scrubbers, which is primarily carbon dioxide and water, but a lot of the black smoke, which has the unburnt hydrocarbons in it. we don't see quite so much of this, but if you've seen a diesel truck pull out from a, a red light and have that big puff of smoke, that's the unburned hydrocarbons. And in fact, Charlotte is still on the list of the 10 worst cities really for ozone pollution. And again, ozone pollution along with unburned hydrocarbons and so on will form the smog. Now this is a picture of Charlotte, and this is on a particularly smoggy summer day. And there are times when, as you drive into Charlotte, you can't see the skyscrapers because of the amount of smog. It usually looks a lot better than this. There are some websites available that you can check this out. One of the activities I'm going to have you do is to look at a website called Smog City and look at some things that generate ozone during the day and then can also help generate all these smoggy conditions. Smog is especially bad when there are situations that keep the smog and keep all those pollutants in the lower atmosphere and don't allow them to disperse. This situation is called an inversion, and you especially see this in Los Angeles when you talk about the brown smog that they get in Los Angeles. So some of that is geography and weather conditions that help this out. In the summer of 2010, compared to previous summers, we had a lot better weather conditions or atmospheric pollution conditions. You can see the flags at schools, green for good, yellow, orange, and then red. And summer 2000, even though it was really hot, seemed to have very few red days and just a few orange days. But apparently the standards also were lowered a little bit, or maybe they were raised a little bit. And that might have been part of the reason that it appeared to be better. Okay. I will go over the Smog City a little bit also, but that will be your assignment, is to look at a website called Smog City and look at how some of these factors play in together.